Hello, today we'll discuss about electron spin resonance spectroscopy. So it's a technique which is similar to NMR spectroscopy, except that we observe the properties of the electron in the presence of the magnetic field rather than the nuclei, which we do in the case of NMR spectroscopy. So the sample which is placed in a magnetic field is subjected to micro radiation, and the sample will absorb this radiation, a portion of this micro radiation, and we observe the absorbance spectrum. So it's a similar arrangement, spectroscopic arrangement, as we commonly have, except that we are using micro radiation instead of light or anything. So this is the setup for ESR spectrometer, and we observe the unpaired electrons. So unpaired electrons, this has this is particularly the case of paramagnetic materials. Paramagnetic materials have this unique property. So I have included a small clip about the paramagnetic nature of materials in the Google Classroom. Please do see that clip. It's a very interesting clip. Now the electron has a net spin. One is due to the orbit rotation around the nucleus. The other one is due to the spin about its axis. Spin about its axis is primarily contributing to its net magnetic moment. And the spin, and in the absence of a magnetic field, say if it has two values, say magnetic spin value is plus or minus half, so they will be in a double degenerate state. So you can assume it's like a balanced state. Now when you apply a magnetic field, just like NMR spectroscopy, some of them will say this unpaired electrons spins will be aligned with the magnetic field, which is in the lower energy state, ms equals minus half. The other ones aligned to the higher energy state, plus half. Now there is an energy difference between the states, which depends upon the applied magnetic field, as in the NMR case. Now what you do is that when you give an electromagnetic radiation, there will be a transition occurring from this low energy stable state to the high energy stable state. The spin transition occurs actually. They'll go to the spin opposed state. So this is the basis of electromagnetic electron spin resonance spectroscopy. So you will in ESR spectrometers you will keep the micro frequency fixed, and then you vary the magnetic field and you make an observation. So it's far more sensitive than NMR spectrometer. Now the output from the EPR spectrometers will be an absorbance spectra, similar to what we have in most spectrometers, but the equipment is designed in such a way that you will take the derivative. Derivative will give you the sharp change. So this is the this is what you the NMR spectrometers, they will give you the derivative of the spectrum, absorbance spectrum. The instrumentation, you have a micro source which is called as a klystron source. Then the sample is placed in the magnetic field. You have a magnetic field which can be varied. Then the sample is placed in this magnetic field, and you apply this radiation, micro radiation. Then there is a detector. Detector is usually a diode detector like thing. It's a rectifier system and a crystal diode. Then the signal processing circuit. So the comparison between ESR and NMR spectroscopy is given in this slide. Do go through. This is one equipment which I have seen personally. This was in our lab next door in IIT Bombay. So this is a ESR spectrometer. There people from various departments to use it. There is a facility called a SIFE there. So hope this helps you.